I guess from the point of view of Atlas Copco, as you mentioned earlier, our main specialization has been in compressors, especially in the area I'm a part of. And we've, let's say, especially on air compressors, developed quite a portfolio of solutions and technologies to deal with different requirements. We're quite flexible in how we handle the gas and so on. And we've tried for the past quite a few already years, I would say 10, 15 years, to implement these kind of solutions, flexible and efficient, also to gas compression. So as some of your readers may know, besides CO2, we have portfolios in natural gas, hydrogen compression, and other gases. Lately, a lot of the focus on technology development has been on CO2. I think mainly because we've seen a large uptick on the requirement from the market to recover and utilize CO2 instead of wasting it or throwing it away in that sense. From the point of view of technology in our side, we've tried to bring kind of different setups for CO2 compression. Now we know there's many different applications and many new applications. Perhaps we'll go into that in a minute. For CO2 recently, which require a wide variety of flows and pressures to get the gas out. So we go from very traditional applications like brewery CO2 recovery, or let's say this kind of fermentation process CO2 recovery, where small flows, relatively higher pressures are needed for liquefaction of CO2 on site or utilization. From that to fertilizer or ammonia-based CO2 recovery, where we need much larger flows based on the scale of the plants. So this is something that we've tried to adjust different components of our portfolio to match from technologies like piston compressors, of course, which are very popular and well known in this market, screw compressors, of course, and for larger applications like sequestration and enhanced oil recovery, where very large flows of CO2 are used, of course, turbo or centrifugal compressors that can manage quite large flows. Based on the applications we see now that are big for us, let's say, on the market, and we have seen as well a good development of, I would say our main experience or presence has been largely on industrial markets, many related to food and beverage applications. This is where we are also quite strong in other gas compression processes. And the traditional one, as I mentioned earlier, is breweries and let's say fermentation-related CO2 management, but also more and more in plants that utilize CO2, so they don't produce it. They may buy it for parts of the process, but compression has become useful as a way to recycle and recover that CO2, reducing the need to buy extra carbon dioxide and just keeping a closed loop of CO2 in their plant. And we've seen quite a lot of these applications, especially in food sterilization and purification processes, where CO2 was before, for example, used in autoclaves to sterilize rice, grains, tea, and other bulk transportation of foods. This was basically bought, used, and released once the process was finished. Now, more and more, many of these, let's say, industries are looking for ways to recycle that CO2. So taking it from the process, compressing it, recovering, and reutilizing it. This, of course, I think goes very hand in hand with the theme or topic of this webinar. I think more people are looking at ways to reuse or use a closed cycle of CO2 in their plants. And as mentioned earlier as well, many customers in the biogas segment, a segment where we're also very active in the compression of biogas, have started to look at these kind of recoveries to make their product more carbon neutral than before, or even carbon negative, as it's called. Because before, obviously, they were recovering greenhouse gas emissions from the associated methane or natural gas that was emitted. Now, besides that, they recover also the carbon from the CO2 that process would, in other words, produce. So I would say, from our point of view in compression, we're looking at all these new processes and ways of handling CO2 that are appearing on the market, from large scale, I would say, in many cases close to ammonia or fertilizer plant setups, to smaller scale, like biogas, food and beverage applications, and so on, and trying to find different fits and the best technology for all these applications. Goes without saying as well that we are very worried or pay a lot of attention to the quality of the CO2 that is managed. Many of these applications are, of course, related to food and beverage, where the CO2 goes directly in contact with the product that the customer, the industry is then producing. So for all of these CO2 applications, we by default use all free compression. And we also have some, let's say, dedicated CO2 treatment portfolio for drying and purification. I think now more than ever, carbon or CO2 purity regulations have been well enhanced. I think that it's being used quite a lot as replacement for other processes in food and beverage. There's been a lot of emphasis in ensuring the quality of CO2, and that is something also we try to do with the portfolio we're working on right now.